move your desk so you can get the view of the screen or whatever. I'm going to start recording some of the things that we do in class and then post them on my website. Okay, so if you miss something in class, or if you need to, and you're taking notes and your notes weren't all that clear to you, you get the instructional part, you can go back and watch the video and brushing up on things a little better. See how that helps us with grades and stuff like that. If it becomes something that is beneficial, we'll keep doing it. If not, probably do it for a week or so and then reevaluate and see if it's worth it or not. But number 9, find the equation of the circle shown in the figure. When you find the equation of a circle, there are 2 things you need. One being the center. Okay, so here we see the center is located at -2, 2. Bless you. Okay, so let's see. Right, -2, 2. So remember it's x minus h squared plus y minus k squared is equal to the radius squared. H and k being the ordered pair, alphabetical. Okay. So now we're going to go x minus -2, so it becomes x plus 2. And then y minus 2. And now we've got to find r. Okay, so r is the distance of the radius, right? So you need to use 2 points that you know for certain exist on this circle. Alright? So my suggestion to you is to go around here and try to find some spots that you know that circle passes through kind of the intersection of grid lines. Okay, so you know exactly what we're looking for. So we're looking for maybe like that point right there. You see how that point is the intersection of the grid line at y equals 4 and the grid line of x equals 1. Okay, you want the exact intersection because we want to use that exact point. Okay, we would hate to use like this point here because then we're kind of approximating is that maybe -1.5. Sorry, -1.75, and then up here maybe it's 5.7 or something like that. Does that kind of make sense? We don't want to have to estimate that way. Now, if we did estimate that way, we'd get something close to what we're looking for. But remember that the computer is looking in this case for that 13. And if you get 12.8, okay, pretty close, right? Still going to mark it wrong. All right. So you want to find either that point there. There's another one over here. One down here. There's one here. It's pretty useful. Okay. As I look at this, thinking of the ones that are useful. Okay. There's one there, and there's one there. Okay. I know I got to use -2, 2. All right. But of those 5 points, okay, I think it makes sense to use either that one or that one. Why would it make sense to use those?
Because they have zeros in them.
Okay, because they have the zeros in them. Okay. So now, what we have to recognize is how this axis is orientated, and we're seeing that so it's 4 markings, 4 tick marks between 0 and 2. So it's counting by halves, right? Okay. So this point here is the one I'm going to use. It would be 0, -1. All right. So now finding the distance, if you remember that's subtract your x's. So my radius is going to be 0 minus -2, so that's 2. We'll square that and get 4. So you take the x's, subtract them, square them. Okay. Add to that the same thing with your y. So we're going to take 2 minus -1. 2 minus -1 is 3, right? 3 squared is 9. So we get r is equal to radical 13, correct? And you would have found the same thing if you would use that point there, that point there, or that point there. Just this subtraction and then squaring process is a little bit easier if we use a coordinate that is a 0. So what is then going to go right here? 13. Just be cautious. I see a lot of people when they ask me questions, they've got everything up here, but they've got a radical 13 here because they forget that that's r squared and not just r in the formula. I'm also seeing a lot of people going through and they come up and ask me questions and we go through this, and they're telling me everything that they need to be doing, so that they're just kind of confirming that they're doing the right process, and then they get back to their desk or go home or whatever, and they type it in, and everything that they've done is wrong, or it's saying that's wrong. And the reason is they're not paying attention to the variables, okay? I saw several people yesterday have x plus 2 squared plus x minus 2 squared, and that obviously counts it wrong because you don't have the two variables. I saw y plus 2 and plus y minus 2, okay? So you have to use x and y. Does that make sense? All right. So that was 9. Go to, somebody wanted to see 10. 10 says show that the equation represents a circle by rewriting it in standard form. If you've been working with anybody, if you see the red numbers throughout the entire year, the red numbers indicate that those are the values that change from person to person. Okay? Which is nice for you to see because maybe you could be working with somebody and now you know how yours, a little bit quicker, maybe differs from theirs. But remember, we wanted to talk about taking the x's, using the commutative property, and rewriting them next to one another. We're then going to leave a blank spot, and then we're going to take the y's, and we're going to do the same thing with the y's. So we go y squared plus 6y plus, leave a spot. And these are always going to be plus signs here between the blanks, okay, because we're going to take a number and square it, and that number should always become positive then. But then we've got to move the 14, move the constant to the other side. Because we're going to complete the square on the red expression and then on the blue expression. So completing the square here, take half that number and then square it. So 3 squared is 9, so add 9 here. Come over here, add 9. Got to keep that equation balanced. Do the same thing here. Okay, so in this case it just ends up being the same 9, but a lot of times those are different. So now this becomes, if you remember from what we call this a perfect trinomial. And we can now rewrite that. Why it's called a perfect trinomial is because you can even rewrite it as a binomial squared. So this term here is always the square root of that term. And then it's always whatever this sign is, so it's a minus sign now. And then that b over 2 term, the term that you had when you took half of the middle. Okay? So for us it was 3, right? So minus 3. And we'll square that. Come over here to the right hand side, or the blue side, I guess. The blue portion. Square root of the first term. Okay? And now plus sign, so we put a plus sign. And then that b over 2, which was 3 again. And then we'll square it. What I usually do, just to make sure I've done that right, just quick, you guys know how to do this quickly. FOIL this back out. X times x, give me x squared. Negative 3x, when I multiply those together, double them gives me negative 6x. And then negative 3 squared is positive 9. So I know that this term here, this binomial squared is the exact same thing as that trinomial. And then I can do the same thing there, and they will match up. So then I get, what, 4 over here, negative 14 plus 18, so I get 4. So when they ask us what the center is, okay, remember it's h and k, and this is always x minus h, and this is always y minus k. So basically what we do is we take the opposite of that number. Okay, so h is going to be positive 3, and k is going to be negative 3. Okay, and hopefully you realize that from that kind of activity of where we move the circle left and right. The x minus 3, remember that moves your circle to the right, correct, from 0, 0. So it's got to be a positive distance on your x-axis for the center. And then the radius, remember, square root that number. Okay, that's usually, I usually don't see too many people struggling with, like this type of question, struggling with those two. It's this one that they keep putting 4 in for. All right. For some reason, it's always a big issue with that r squared that throws a lot of people off. Okay. 11. I know somebody wanted to see 11. I'm going to skip it just to save some time, but it's the exact same procedure. Okay, it's the exact same question. You're just now dealing with. You're going to take the x, take half of that, you'll get 4, so you add 4 to the left-hand side, add 4 to the right-hand side, and then 14y, so say you'll add 49 to the left and 49 to the right. You should be able to write as a binomial x minus 2 and a binomial y plus 7. And then the right hand side becomes 16. Was there anything in regards to like the symmetry that we wanted to talk about, any of these questions? You guys felt comfortable doing that stuff? Alright. Second. Your question? Or? No, you're good? Okay. Remember, that's just plugging stuff in, okay? Just kind of rehash real quick. If I want to do x-axis symmetry, okay, that said, if you have the point x comma y, what's the other point that should exist if you have x-axis symmetry?
X comma negative y.
X comma negative y, good. Okay. And basically all that means that if I want to see if this thing has symmetry with respect to the x-axis, all I've got to do is where I see an x, I plug in this point. Okay, so I'm going to plug in this information here into this equation. So wherever I see an x, I plug in x. And wherever I see a y, I'm going to plug in negative y. And I'm going to go through the entire problem. However many times I have to do that, I'm going to evaluate and simplify that expression. So let's just do an example here. So if I got x becomes x, that's pretty straightforward. But this y becomes negative y. And you just got to make sure that when you substitute, you're substituting the entire object negative y. Okay, because that becomes now negative y times negative y. If we didn't put parentheses around that, we're not fully substituting kind of a one-to-one idea there. So then plus, okay, x stays x because that's what this point is saying to me. And then this y becomes negative y, and we're going to see if that equals 9. So if I go through and I start evaluating this, well, negative y squared, or not evaluate, I keep saying the wrong word, simplifying this, negative y squared is just y squared, so we get x squared, y squared. But over here, this becomes negative xy equals 9, right? So you simplify things, and when you're fully simplified, you get all the way down to that, you take that and you compare it to what you started with, okay? If they are the same, then your answer to the question is yes, we have symmetry about whatever axes or the origin. But if they're different, you don't have that symmetry, okay? So we see here, obviously, it's got the solution highlighted. The graph has symmetry with respect to the origin. So let's just go and see what that would look like for us. Once, since we know that's going to happen, maybe we can do the algebra and see the outcome. Okay, knowing that it's kind of a trivial thing since we already know the answer. So if it's symmetric with respect to the origin, it's opposite x, opposite y, right? Okay, if xy is on my graph, and so is this point. So we're going to start plugging things in. So everywhere I see an x, it's now negative x. Everywhere I saw a y in my original thing, it's now negative y. Plus then x again is negative x, y is negative y, equal to 9. So I square this one, square negative x gives you x squared, square negative y gives you y squared. Okay, now over here, a negative times a negative is just a positive, right? So xy again, and I get 9. So that's the simplified version after we substitute. Is that identical to what we started with? Yeah. Okay. Now, the reason they give you questions like this is because they know, as an author of this question, you guys have TI 83s and 84s at your disposal. Okay. WebAssign is kind of designed for you to use it in conjunction with that calculator. Okay. There will even be things in these assignments that say, using your TI 83 or 84, do this. Okay. So they know you've got your calculator. And they know that you can probably look at things and from that calculator graph and say, oh, this is symmetric about the x-axis or the y-axis, and get that answer real quick, right? So that's why they're giving you pretty nasty looking functions here, because can I type that into my calculator? No, because my calculator is predefined to be y equals, and everything over here has to have an x in it. So you can't rewrite that very conveniently to graph. Now if you're using the GeoGebra stuff, that would obviously be something that you can do pretty quickly. Okay, so you're going to see some stuff where they create expressions or equations, knowing that it's going to be very hard for you to use technology to get a quick answer, and they want you to go through the process, and that's what I want you to do as well, is learn the ins and outs, and then we'll come back later and say, okay, now that we know how to do that, let's now use our calculators to circumvent the work, because we already know how to do it. All right. Is there anything else on there, you guys? I mean, I know that was basically my question, but we feel comfortable with everything so far. Circles, symmetry, Let's talk. Let me do this real quick. Number 9. The key thing with number 9 is, and I don't know, Quinn, whether from question to question whether this is going to, I would think it's going to be a consistent idea, but I don't know what all the different types of problems are going to give you here. But when we use, hopefully we realize at the center, you know, that's the h comma k, right? So that's the, let's see here. Alright, so we got negative 4, comma 4. So that's where we're seeing x minus negative 4 and y minus 4. But now to find the distance, to find the radius, I saw this in the last class. People were like going over to like that point right there and saying that is located at like 0.5 comma 4. Okay? Don't do it that way because we're not 100% sure if that's 0.5 comma 4 because it might be 0.48 comma 4. It might be 0.475 comma 4. Does that make sense? It's not. We're not really good at kind of guesstimating what that's at. Now, if you got 20.25, the answer for you was probably something really close to that. Okay, if you go back and reevaluate this, kind of using maybe a different point, you should get something really close to that. But if we circle the or go around the circle here, and what I want to do is I want to find some points that intersect at grid lines. Now, my calibration is kind of off there on my computer, but I want to find a point that I know intersects exactly at the apex of those two grid lines crossing, okay? Because that tells me 100% that I've got whole number or integer ordered pairs instead of having to guess maybe what that rational number is there, okay? So I'm seeing that it looks like that point there is crossing at two grid lines, and there should be a series of others. There's one, there's one, there's one, there's one, there's one, there's one, and there's one. So those are all maybe convenient points. The last class we did a question of this, and I think there's only like 4 or 5 points. This looks like we've got at least 8 that we could choose from. Now it doesn't matter which ones you choose. I just think that if you're going to do this, be thoughtful of the process and know what you're going to do next. We're going to use a distance formula, right? So distance formula has, if we write it out, we're doing some subtraction between x's and y's, right? What is the easiest number to subtract from something? 0, okay? So if I can, I'm going to try to use maybe a coordinate that has, or a point that has coordinates of 0. So maybe I use this one where it's 0, comma 6. So now when I subtract my x's, negative 4 minus 0 is easy. That gives me 16 when I square it. And now I'm going to subtract my y's, so I get 6 minus 4 is 2. Square that gives me 4 again. So there I get radical 20. Okay? Now remember, that's the distance of that segment right there, right? So that's your radius, correct? What is this form or value in our equation? What form is that in? Radius squared. So if this is r, then r squared is just 20. Okay? So does that make sense then to choose those points that are maybe a little bit easier to guesstimate, or I guess eliminates guesstimating. If we look at this, so for instance, let's say you chose, I don't know, let's say negative 4, comma, that point looks like it would be, it's 9, 8.5. Okay, if you did this, you would probably get, with those two, you would probably get 20.25. Very, very close, okay, to the actual 20. But what that tells me, because they're not the same, that this point here really wasn't negative 4, comma 8.5. Does that make sense to everybody? Okay. And we could quickly maybe do that on GeoGebra and actually ask it what that point is, and we'll see that it's not 8.5. Last class had the same question, so that's a good way to talk about that. Anything else? Any other?
Would you like a donut?
No. I'm fat, and I'm trying to not be so fat. But thank you, I appreciate it.
Ethan, I'll take a donut. I'll take one.
Would have anybody, if I would have taken a donut, anybody would have bought it off of me?
I would consider.
16.
I don't know. I agree.
Good. All right, so when you see questions like this and it says test for symmetry, if you remember yesterday at the end of class we talked about this. When you're testing for symmetry, you're going to have three options, and you might have symmetry across different axes. I mean, you might have symmetry across the x-axis only, but you might have symmetry across the x-axis and the y-axis. Okay, if I have a circle centered at 0, 0, I've got axis around all three things we talked about: the x-axis, the y-axis, and the origin. Does that make sense? You think about folding that circle, and you see it's going to fall on itself a lot. So when you're doing this, just because you find yes for one of these, doesn't mean the other two are no. Does that make sense? You've got to test them all. And we talked about, let's see, can I zoom in on this? If anytime you guys can't see the equation or the expression, let me know. I don't like that either. Let's do it this way. So we're taking x to the 6th, y to the 6th, plus x to the 4th, y to the 4th equals 9. Now, that's an ugly equation, right? Okay. And you're going to take, maybe you would try to solve that for y. You're going to find out that maybe that isn't even solvable for y. You can't isolate y to the first power all by itself. There are equations that exist like that. Okay. And the reason they give this to you is they know that at your level you are using a TI 83 or 84, right? And if you're able to type in an equation, say I gave you y equals like x squared plus 5, and you weren't sure about the symmetry, but you can type that into your calculator and say, oh, I can fold that on the y-axis, it's got y-axis symmetry. You can get the answer real quick, right? Without having any algebra understanding. Giving you questions like this, testing the same thing, but those types of equations eliminate your ability to use the calculator, okay? Unless you have an implicit graph, for instance, GeoGebra, just while we're waiting for that other thing to load. If I were to go to GeoGebra, I can go, and this is another reason I'm not going to let you use this on a test, but I can go x to the 6th times y to the 6th plus x to the 4th, or y to the 4th, equals, I think it was 9. And we can graph that, and it does a really, really good job of graphing that, right? Okay. And then hopefully you can recognize that that's probably got x-axis symmetry, it's probably got y-axis symmetry, and it kind of looks like it has symmetry about the origin, right? Okay. So you could get that question if you had an implicit grapher, you could go ahead and do that real quick, not know any algebra, and get the right answer. They're trying to inhibit you from doing that. And here you're seeing they label it as an implicit curve. So what that tells me is that GeoGebra is recognizing you can't solve this for y. If you remember yesterday, we clicked on that and we were able to change the format. Okay, it was either an expanded form or a form that solved for y. Here it doesn't have that ability, so it's telling me that it's not solvable for y. So here's the algebra that you would have needed to go through to figure this out. If I've got x-axis symmetry, let's just write the rule down here for x-axis symmetry real quick. says if I have the point x comma y on my graph, if x-axis symmetry exists, what's the other point that we have on our graph? Good. X comma negative y. And I've been writing this arrow going one way, but it's actually a two-way street. If x comma y exists, then x comma negative y exists, and vice versa. So now we're going to test that, see if that exists. Everywhere I see an x, so basically the equation right now is set up in regards to that ordered pair, x comma y. We want to see, do we get the exact same equation when we use that point? So we have to substitute things with that point. So again, x is going to substitute as x, so we still get x to the 6th. Okay, but now y is going to substitute as negative y, right? So we get negative y to the 6th. Plus then, x again becomes x, so x to the 4th. And then y is now negative y. And that equals 9. My suggestion to you throughout every course that you take from this point to your last math class that you ever take, when you substitute something, whatever you're replacing it with needs to be in its own set of parentheses. Does that make sense? So that you make sure that exponents and maybe distributive property and that kind of stuff gets taken care of in an appropriate manner. If I would leave those parentheses out, what I would be writing is that the y is getting raised to the 6th power, but the negative is not. Does that make sense? Well, we want to make a full substitution. Okay. So when we do this, we have to now simplify. So x to the 6th is simply just x to the 6th. But what's negative y times 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 negative y? Y to the 6th, right? If you have even number of negatives, it's going to evaluate to be a positive number, right? Negative times negative is positive, however many times you do that. So negative times negative, negative times negative, okay? You got 4 of them, positive. 6 of them, positive. 8 of them, positive. So x to the 4th then stays x to the 4th. That's what's negative y to the 4th going to be? Y to the 4th, and that should equal 9, right? Once we simplify, once we substitute and simplify, if what you're left with is exactly with what you started with, what that tells you is that you have symmetry about the x-axis. Okay. So yes, we have x-axis symmetry. Okay. So now we're going to do the exact same thing, but we're going to do it with y-axis. So y-axis symmetry, we're looking at the point x comma y. If that exists, then negative x comma y exists. So it's the same procedure now. Plug things in with this point. So x is going to be negative now, right? And the y is going to stay y. So we're going to go negative x to the 6th, y to the 6th, plus negative x to the 4th, y to the 4th, is equal to 9. Well, for the same reason as before, that's going to become positive x to the 6th, y to the 6th, plus positive x to the 4th, y to the 4th, is equal to 9. Is that exactly what you started with? So now we have y-axis symmetry. Okay. Now we could cheat and realize that picture-wise, if you have folded something along the x-axis and it had symmetry, but then you also fold across the y-axis and it has symmetry at the same time, you're going to have origin symmetry. Okay. But what I think is useful is maybe to actually go through the process and say, if I have x comma y, so this is for the origin, that's going to be negative x, negative y, right? Okay. And we talked about that. That is also, if you remember back to geometry, that's a 180-degree rotation. They're synonymous for one another. So now everywhere I see